Okay, so afternoon, everybody. I we we are currently about an hour behind schedule, so I think it is good that unlike previous years, my presentation is no longer 2 hours long. It is. Like last year it was 2 hours because I was doing a tutorial on Julia. But today what I want to talk about is about the GeoRegions ecosystem, which is basically a series of packages that I've developed for my own work, which is basically on the the downloading, extraction, and analysis of gridded data, for example, for GPM, iMerge, or for ERA5 reanalysis. So the purpose is also to give some updates on GeoRegions ecosystem, where things stand out, and also get some feedback because there are a lot of people who I would like to talk to who are here, like Anshu from Julia, who because I recently moved GeoRegions from I think it was Polygon Ops to Geometry Ops, and then part of the Julia Geo package. And I'd also like to integrate the GeoRegions ecosystem together with the Julia Geo community as well, if possible. For example, I've been hearing things just now. Raphael was talking about rasters, and I think there's quite a bit of stuff that could be integrated into the GeoRegions ecosystem, and also. Show people some examples on how to use the packages that have been developed on top of the GeoRegions ecosystem for my work. And if you're interested, there are always example notebooks that can be found on GitHub. Although I will say that right now the GeoRegions ecosystem is undergoing another phase of development because I had a moment of inspiration 2 months ago, and things are now rapidly breaking and changing again. So the GeoRegions ecosystem, the GeoRegions is short for geographic regions, is meant to easily streamline data downloads, extraction, and analysis, which was developed for my own work because I needed to use GPM data all the time, and ERA5 data all the time, and ERA interim data all the time. And I'm thinking of extending it to MERA2 reanalysis also, and other data sets that NASA produces as well. So because a lot when I do my analysis, I'm interested in generally specific regions around the globe, but a lot of these data sets are provided as global data sets. So ERA5 data sets, for example, are provided as a global data set. NASA precipitation is also provided as a global data set. But what happens if you want a region of, if you have a specific region of interest? So what happens is that you extract the relevant data from your region. So for example, this is the basis for most of my packages. So for this is ERA5. I use georegions.jl and the packages built on top of georegions.jl to extract data specifically for the Philippines in this example. For example, and this is for surface temperature here. So the GeoRegions ecosystem currently, you can define GeoRegions in two ways. One is it is a rectangular region, which means you specify the north, south, east, west boundaries. And the second method is as a polygonal region, where you specify the shape in terms of longitude and latitude. So I'm going to talk about an example. I'm going to show it. The first thing I'm going to do right now is going to show you an example of how I would do the data downloads and analysis and stuff like that using GPM iMerge, so precipitation data. This example that I'm going to show you is built off the package NASA precipitation.jl, which is a package that I created to download on top of GeoRegions.jl, which is used to download, again, precipitation data, and also relies on NC datasets, which Alexander Barth developed, and also dates.jl, which comes inbuilt into the Julia package. So today, the example that I'm going to go through is that we are going to I'm going to provide you guys after the talk with an example script of how to download GPM data. Because downloading the data would take too much time and would take too much space on your laptops anyway. So it's best for you to go back home and do this example when you have more time. But what I will show you is how to extract the radar data. So the example that I'm going to show you later is that I've already downloaded the entire square. But what I'm going to show you is I want to extract the circle within the square. And then we're going to find the spatial distribution of precipitation from 2001 to 2020 over this region. So this is a snapshot of the radar precipitation over Singapore. I'm going to show you how I do some basic analysis with NASA precipitation.jl as well. So, okay, so this one, let's move this over to here, is it? Yes, sorry, okay, here. I am going to do this. So here. So what I'm going to show you is so what I'm going to do is I'm already in the folder. Oh, okay, yes. Okay, better? Okay, much better. Okay, so active. So basically, I'm already currently in the folder that is Singapore Radar. So basically, this is the project that contains all my data and stuff. So if you look inside, there's the data here, and then there's all sorts of data here. So what I'm going to do is I'm going to show is that I've already downloaded. As I mentioned, I've already downloaded the data for this square box SGR, which is labeled SGR. So let's do using Dr. Watson, and then activate this, and then using sorry, I'm literally typing using NASA precipitation. Sorry. Oh, I forgot to capitalize the P. Damn. Okay, so for NASA precipitation automatically re-exports GeoRegions.jl. So all the functionality that you see in GeoRegions.jl will be replicated here as well. So let's do GeoRegion SGR path equals to source directory. So what you will see is this is an example of loading a GeoRegion. So a GeoRegion basically here contains in this case, because it is a square, it contains the north, south, east, west boundaries, and you can see the ID, the parent ID, etc., that SGR is based on, and then the NASA precipitation data. So basically, the NASA precipitation data set is iMerge final day, and the start is equal to 2001. Start is equal to date 2001. Stop equals to date 2012, and the path is equal to the data directory. And this is an example of a NASA precipitation dataset. So for a dataset, you define the start and the end dates of the dataset that you want to perform your analysis on or your extraction on, and the path is where your data is located in this case. So data directory in this case is the data folder for this project. I'm not going to Dr. Watson today, but it's basically an offshoot of so basically Dr. Watson's for project management, and this is a shortcut function that allows you to specify the data directory. So with the NASA precipitation dataset, what you can do is that you can download the dataset for the dataset. So NPD, you download the dataset for this GeoRegion. And what's happened here is that I've already downloaded all the data, and I've specified that I don't want to overwrite. So because I specified I don't want to overwrite, it's basically scan choose all the files for all the dates, and if it is already there, it just skips to the next one, and because I downloaded all the data, it is already all there. So what I'm going to do next is that, so this is the downloading part, and what I am going to show you now, PyCall, is that I'm going to plot the data equals to PyImport proplot. Is that I'm going to plot the data, and then I'm just going to show you an example of plot from I'm just going to show you how I usually do the plotting. So how I call the data. So in this case, it is read. So I read the NASA precipitation data set for the GeoRegion for a given date. So in this case, I have extract. So in this case, because it's built on top of NC data sets, this is the data set here for NC data sets. So the data set is, so the longitude is ds longitude, lat equals ds latitude, and precipitation equals to ds precipitation. And let's just do it for the fifth time element of this one. Oh, the first one. Sorry. Okay. Okay, we got that. And then after that, what I'm going to do is close fix s equals to product plots. And then what I'm going to do is, do I have this? Yes, I do. One p color mesh lon lat precip did I do this wrong? Oh, the first one is sorry. Okay, and then if we go back to have a look and see in the project folder, we have that okay, so we have, okay, I'm going to open this and I'm going to just drop it here. Do I have, I'm just going to add, no, sorry, wrong one. Here, okay, I'm going to drag this into here, and basically what you see here, this is basically precipitation. For example, I don't have the coastlines right now, but this is basically a melted precipitation. So in this case, so basically that's basically how you basically read the data. That's basically how you download and you read the data for. That's basically how you download and you read the data for the NASA precipitation data. And then what I'm going to show you right now is is that for this case, what we want to do is that what I did is I downloaded the square. So what I'm going to do now is I am going to define a second georegion in this case, which is going to be a polygon region. So in this case, this radar data is centered around the Changi weather station here, the Changi weather station at 103.99 degrees longitude and 1.36 degrees latitude and around 4.8 degrees in size. So in this case, what we do is that we see that the x it's basically a circle. So what we do is we define the shape, which is a circle. So in this case, it is 103.99 plus, okay, broadcast plus sine, this is range of, sine dot, which is range of 0 to pi and 100. And then y is, sorry, this is going to be cos, sorry. This is going to be cosine, and then y is going to be sine. So y is going to be, no, this one should be cosine, and this one should be, 1.36, and then this one is sine. And what you see, and then what you can do is you define a new georegion. This one is going to be a polygonal region, so it's poly region, SGR2 within SGR, and Singapore weather radar 2. Oops, sorry. 2, and then X, and then Y, and then path equals to source directory. So what you see here is that this is a polygonal region, and then this polygonal region, the polygonal region is defined by the north, south, and east, west boundaries over here, and you have basically you have the shape that is the circle. And then if you want to plot the circle here, this is going to be ln 1 let 1 equals to coord GeoRegion geo2, and then let's just plot this again. axs 1 plot ln 1 let 1, and then you see that it is within the circle over here. So basically, if you want to extract a region, it is. So basically, when you extract the data, you will extract the data for this circle over here, basically. So if you want to do the extraction, also I realize I defined this one wrongly, because this one is supposed to be x is supposed to be 4.8 times this, and y is supposed to be 4.8 times that as well, 0.8 times that. And then let's define GeoRegion again. Okay, it is already in use. Okay, remove GeoRegion, SG2. Sorry. Oh, sorry, I need to do path. Sorry. Path equals to source directory. Let's try this again. Sorry. Path equals to source directory. Okay. Oh, sorry, SGR2. Sorry, this one's SGR2. And then we try defining this again, and then let's do the axis plot again. And then fig. Okay, and then oops, ln 1. Try this again. Yeah, and so this is the green one is the correct circle. So that's the correct circle. And then what I'm going to show you is that you can extract the data for the circle. So for NASA precipitation data set, you can extract geo2 from geo. Okay, so this one is so basically what you're seeing here is so basically what I'm showing you is that you can extract the data for the square GeoRegion into the circle, and then what happens is that if you look into the source folders here, you will see that in the data where you have the unmerged v7, you will see two. So initially there was only SGR, and now there's SGR2. So SGR2 is basically you've extracted the data out from SGR for that circle that you've seen here, from that square into the green circle. Okay, so what I'm going to do next is that I'm going to sum up the data. So using this one is using Dr. Watson, and then activate this, and then using NASA precipitation again. NASA using NASA precipitation. Oh, need a big P. Wait, shit, sorry. Oh, sorry, wrong one. So you need to go back to this one. Using Dr. Watson. And then this one's activate this one. and then using NASA precipitation, and then NPD, and then Geo. Geo equals to this one. Let's do SGR2 in this case. And then what we're going to do is that for all the dates within not NPD start to NPD stop, we are going, so after that, what we're going to do right now is that we're going to read this. We're going to get the longitude and latitude. Here, we're going to get the longitude and latitude. And then what we're going to do is we are going to get the, and after that we're going to temp array equals to zeros of length, lon, length, lat, and then for IDT equals to month, equals to npd dot start to month 1 to npd dot stop. Then temp array equals to ds, you get ds equals to read npd, geo, and IDT. Temp array plus equal to mean of the ds precipitation dimensions 3, and then after that, this one, okay, and then you end this loop. Yeah. Mean is not defined. Okay, using statistics. Statistics, and let's try again. And then after that, what you see is it loops through all the files and then it adds. And then after that, let's do the plotting again using pycall. Proplot equals to pyimport proplot. Sorry, wrong one. So plot equals to this, axs1 equals to this, and then we do the temporary array. And then we do the fig, say fig. And then we see that now instead of having the square, we have a circle. So basically with that, what I'm trying to show is that with NASA precipitation datasets, you can do, which is built on top of GeoRegions, you can basically do downloading, extraction, and some basic analysis of precipitation data. So So with this kind of functionality, I've also replicated basically for ERA 5 as well, and I'm also looking for other people who will be willing to use the GeoRegions ecosystem to build on top for other datasets and other packages as well, such as MERA2 reanalysis. So this will help streamline a lot of use cases for other people as well. Yes.
So just to clarify, we started off with a data set and you created a boundary of interest.
Yes.
And then what you basically did is you zoomed in.
Yes.
It's not like some kind of projection of someone.
Yes.
It's like a zoom in of average.
It is a zoom in of that region. It's basically you're taking the region that is relevant to you. You're taking that data and then you're extracting it and you're saving it in a complete. You're saving it as its own separate. In its own separate files, so for easy extraction. So this is useful if, for example, you have a global data set and you don't necessarily want to save that global data set because you're only interested in, say, the maritime continent region, or say Brazil, or say maybe Terceira. You don't want to save global data just for that. So with this functionality, what you can do is you can extract the data that you need from the global data set. So you temporarily download the global data set, you extract what you need, then you can delete the global data set, and you have, and basically you have the data for that particular region of interest. Right. So yeah.
So what I saw earlier in your original unfiltered version, the region was mostly white. So
because this is the summation of all the data files. So basically what you saw down here was the for loop. I opened all the files, I did the summation, and then after that I produced an image like that. So this is how you can do quick and easy analysis, because this is for 20 years worth of data, and what I showed you with the square initially was 1 day. So each file in this case is daily data, but each file is every month, so 1 month's worth of daily data, and I iterated it over 20 years worth of data. So with that, and I got this is the temporal mean over 20 years worth of data, for example. So this is how you can do some basic easy analysis with NASA precipitation, which is built on top, of course, of the GeoRegions ecosystem as well. So I've gone through how to extract from SGR into SGR2. I've gone through how you could easily use Julia and NASA precipitation in order to extract and sum out the precipitation data from 2001 to 2020. And then of course, you can see the spatial patterns. Actually, if you look close, if you know the geography here, you know that this boundary here, this arc here, is Malaysia, and then what's on the southwest is Sumatra, for example. Like that kind of space, you can do some kind of basic spatial analysis, for example. So this is an example of NASA precipitation, which is built on top of the GeoRegions ecosystem. So the GeoRegions ecosystem right now, in the example that I've shown to you, is based on GeoRegions version 6, which is a dependency of NASA precipitation, which you see on the bottom left. And also I have created a similar package for ERA 5 as well, which also does the downloading and which can do the downloading and the extraction and time series, some basic time series stuff, and spatial smoothing and temporal smoothing as well. I'm also planning to do this for other data sets as well, but what's captured my attention mostly in the last, let's say I have 10 minutes. For the last 4 or 5 months, or maybe 3 months, has actually been to rewrite GeoRegions.jl into 3 different packages, because what happens is that GeoRegions.jl got too big. So there were too many dependencies. So initially, GeoRegions.jl, you were defining geographic regions, you were doing the extraction of the regions, and then you were also doing land sea masks. So for example, if you're interested in the contrast of precipitation over land and sea, for example, for NASA precipitation, they provide, for example, a land sea mask. So you have, for example, this point is land, this point is ocean, this point is somewhere in between, and it can become useful for analysis if you want to, for example, understand the coastline, for example, because that's both land and ocean. So what I'm doing is these were the main 3 points of GeoRegions, and what I'm doing right now is I'm splitting them up into 3 different parts, one specifically for defining GeoRegions, one specifically for extraction, and one specifically for land sea masks. And then after that, all the sub packages below. And the top three packages are what I call the GeoRegions ecosystem, and everything below is dependent on the GeoRegions ecosystem. built on top of it. So when it comes to downloading and reading of the files, these are handled in the respective packages at the bottom. So for example, NASA precipitation, you have your own download functions because each dataset has its own downloading quirks and whatever. And the same for ERA 5, which uses the climate data store, and then eTopo also is I think on OpenDAP servers. So all the different packages have different downloading stuff, but I just wanted to be able to streamline the downloading analysis for a specific region of interest, because that's the point of the ecosystem. And also, in the past, you used GeoRegions, so Geo used to be part of the GeoRegions, the Julia Climate organization, and now it's been separated into its own ecosystem for own organization for its own ease of management. If you want some example notebooks, the GeoRegions ecosystem organization has notebooks as well has Pluto notebooks as well that you can use for examples. So as I mentioned before, these three packages, GeoRegions, Region Grids, and LandC, they act as the base of this ecosystem. And all the other packages below for NASA precipitation all build off this ecosystem. So what this GeoRegions ecosystem does is that especially it is useful for OpenDAP servers. So for example, a lot of precipitation data is stored on what we call OpenDAP servers. So it's basically managed by NASA, I believe. And what you can do is, instead of having to download the global data, you can use GeoRegions and region grids to say, I'm interested only in this specific part of the global data. So from this index to this index, and then I will retrieve it directly from the OpenDAP servers, and I will save it onto my computer or save it onto my server. So it streamlines that process for you as well. The reason why I'm pushing from GeoRegions, what the example I showed you was based on GeoRegions version 6, but this ecosystem is for version 7, is because I want to make the GeoRegions ecosystem more project friendly. So basically you can define, each GeoRegion is tied to an ID. So basically by making it more project friendly means that for different projects, you can use the same ID for different boundaries. So you can have SEA boundaries, Southeast Asia boundary. For a specific project, you might have it as a polygonal region, and for another project, you might have it as a rectangular region. But for different projects, these GeoRegions won't overlap with it. They won't clash with each other if you're specifying for a particular project. Yes.
So, I find this package very cool. And one thing that kind of came to my mind immediately when we were talking about using these polygons to kind of set your boundaries and put that of interest is that on Google Maps, there's a lot of metadata on boundaries of countries, cities, etc. And I find it interesting that perhaps there's some kind of synergy there where you can take that boundary and then use this polygon, like search it, and actually have a real boundary of the country, for example.
Yes.
Rather than just a circle or a square, and extract out of that. And I think that would really make it a lot.
Yes. So I think who is it? Benoit Pasquier has been pushing me to define the ocean basins, for example, as polyregions. I've been trying to do that, but I've only recently had the time. And also, I've also had some predefined GeoRegions, and I didn't show them in today, but I have for the AR6, which is the IPCC 6 boundaries. I have them as predefined regions. I have two other sets of GeoRegions or regions, like regions in the globe, defined as GeoRegions as well, predefined in the package as well. But I also welcome if people have the boundaries of interest that they want to see in GeoRegions or JL, just to give them to me, and then I will read the file, and then I'll read and I'll put them as predefined GeoRegions. So I can do that as well. Ocean basins is a bit tricky because I think there are regions within regions, and that's something that I want to explore with Julia Geo, because this particular package is based on simple polygons. So it does not have polygons within polygons or polygons with something inside that is not valid. You know what I'm saying? So Yeah, that's another possible another extension of GeoRegions that I want to investigate further in the future. Yeah. So does that answer?
Yeah, I
Yeah.
was gonna say because usually boundaries are not really polygons are like most fractal. Like
Mm-hmm.
that wouldn't really matter in the case that as long as you have a rough region, that's more than enough.
Mm-hmm. Yeah, so it's that kind of thing. It's basically the kind of thing that's basically the purpose of GeoRegions.jl. So it's extendable for anyone who has their own set of polygons or set of regions that they're interested in, and they have the boundaries and not the boundaries, but the shape of that region. They can use this package to define a GeoRegion, and then based on the definition of the GeoRegion, they can download, analyze, extract data for spatial data. Yes.
I had two thoughts. My first thought was, do you think you could you have all these different packages for accessing the different data?
Mm-hmm.
Could you develop a common API to access the different data sets?
So basically what I do is that download, so basically for example, download, if I'm downloading data, is that I extend the base functions of Julia. So Julia has the download function, then I extend the download function. So I download a dataset and a GeoRegion. And the download thing, and the same for ERA 5. I have an ERA 5 dataset, I download an ERA 5 dataset for a variable for a GeoRegion. But because when you're downloading data sets and you have to specify that there is this data set that you want to download, and you have to specify that there's this variable that you want to download, especially for ERA 5 or for reanalysis data sets in general, and then you specify the GeoRegion that you want to download. Like you have to specify all these things in order for the downloading or the analysis or the extraction function to be useful. And that's something that I've learned in the last 4 or 5 years when I've been trying to handle different data sets using GeoRegions.jl. Does that make sense?
Yeah, but have you figured out what the commonality is between all of the access patterns to these different data sets that you can?
The problem is that a lot of them are on different servers. So NASA Precipitation is in OpenDAM, which has a different access format from ERA 5, which is stored on CDS, the Climate Data Store, which has its own API as well. So the best that I can do as of now, or that I know of as of now, is to streamline the front end functions that people want to use for download, analysis, extraction. And then on the back end, I would do the finagling of the details of how you do the downloading, or how you do the downloading and the retrieval of the dataset from the online server, for example. So that's why I have several different packages for all the different datasets, and I don't foresee that that's going to change. Unless you want me to have a master package that basically is a re-exporting of all the different packages below, but that would probably defeat the purpose, because people are also not always going to be interested in one data set. In all the data sets, you're probably going to be most interested in one data set or another data set or another data set. Like people tend to use either, for example, ERA 5 or MERA 2. I don't necessarily see people using both data sets unless they're doing an intercomparison between the data sets themselves. So it really depends. So as someone who does lots of the front-end management of these kinds of data sets for my own usage, I am not sure, I'm personally at this stage not too sure how or if I even should combine all these data set packages into one package. Yeah. I just want them to have a common set of functions and a very, very similar method to call these functions for ease of use. Yeah. Yes.
I think I should ask, is there an upstream package that helps you define GeoRegions?
Uh,
That are more related to actual boundaries on the planet that's or whatever. It seems like a critical part of the infrastructure to have a full pipeline. Like the data rate is certainly important, and then after that, part of the work was to define the GeoRegion. I think it's very interesting if there was something that would actually.
Like right now for me, GeoRegion, I actually define GeoRegions in the GeoRegion package itself. So the GeoRegion, I have several different ways to define GeoRegions. One is a rectangular region where I just specify the north, south, east, west. One is a polygonal region, I specify the x, y of the shape. So that's how I currently specify GeoRegions. I'm not sure if that answers your question.
No,
Yeah.
I was saying whether or not there was an upstream package that would kind of be more sophisticated in its ability to generate these regions, whether from actual data of maps and whatnot. Kind of relates to what I was saying before, but it does answer the question. I would assume that there is no separate package.
There's no separate package. Yeah.
That would help you define these kind of.
Yeah, I mean the only way, because a lot of these regions are defined, like for example, country data, they are defined, I think a lot of them have GeoJSON, so I would have to read the GeoJSON data and then put it into a specific format that for this package. Yes, Anshu.
Sorry, just another comment. There are a couple of packages.
Mm-hmm.
But if you're asking specifically about getting data, let's say you want the border of the country or the entry data of the country. So there's a package called GADN.geo, which gets like national and subnational borders all the way down to usually a district level. That's like sub-state.
Mm-hmm.
And there's a package called Natural Earth, which gets you country borders, resolutions, and also the locations of cities.
That's very helpful. Really like a machine learning competition is so easy with people just driving that from country.
Yeah, I mean, that's the idea, right? Is that ultimately everything becomes a standardized interface that is, I want this data set, just get this data set, and I can ingest it. This is the idea of geometry, right? I ingest it, I don't have to know what this is. I just know the nature of it, that it's geometry. And I say, okay, I have I have a time grade analysis data set, and I want to get, the average precipitation predicted for this year, for example.
I have a question.
Yes.
In Brazil, we commonly use socioeconomic regions,
Mm-hmm.
right? So we can download it by the government in shape files.
Mm-hmm.
So I'm looking at the documentation
Mm-hmm.
here. So I could just call the shape file, inform what the column is the polygon,
Mm-hmm.
and create a region for that socioeconomic.
Yes, so basically what you need is for the shapefile, you'd have to have I assume you have the longitude and latitude boundary points, right, that define the shape, right? So what you can do is, as example just now, you just define a polygon region, and then you have x equals to the longitude points, y equals to the latitude points, and then after that, you just define the GeoRegion, and then you can just use the GeoRegion for analysis of, say, NASA precipitation data example. Yeah.
Yeah, I could also use multi-polygon.
Hmm?
Multi-polygon information.
Mm-hmm.
So it would work.
What polygon, sorry?
There is like multi-polygon.
Oh, multi-polygon? I haven't done the multi-polygon thing yet. The multi-polygon thing is something that I want to do for version 8, but I haven't had the opportunity, because all these are simple polygons. I haven't had the opportunity to reorganize the package such that I can have polygons that are separate, so different polygons, or a polygon with a large region where the data is mostly valid, but some interior area where it's not valid, you know what I'm saying? So I haven't progressed to that particular stage yet. It is on my to-do list. I hope to integrate it with Julia Geo in order to make that happen. But for now, it's not something that I have done yet, if that makes sense. Yeah, of course. But it is something that I am looking to do in the future for more complex domain analysis or more complex regional analysis. Yeah, but that's something that I am thinking of doing in the future. Yeah. Mm-hmm. So so with that being said, it's just that I was splitting it because GeoRegions.jl was getting a bit too big. There were too many things going into the single package that was meant to be lightweight. So it's easier to maintain the 3 different packages, GeoRegions, Region Grids, and Landsea separately. So just some future plans. So GeoRegions, as I mentioned before, has switched dependencies for polygon operations, because quite often when you're doing analysis, especially if you want to do extraction, you want to know that the data you're extracting the region from is within the bounds of the data that you have. So sometimes you want to show that a region is inside another GeoRegion or a region is on the GeoRegion. So I switched from Polygon Ops to Geometry Basics. I'm asking for help for that for the people that are here in order to learn the ropes for the polygon operations. There are also more extractions for region grids. So basically, previously region grids, what you had to use a rectilinear longitude-latitude grid. I am currently in the process of extending it for more generalized and unstructured grids. So for example, it will be useful for WRF. So this is a WRF domain here. So WRF is the domain the data output is not on a rectilinear longitude-latitude grid. It is quite often on whatever domain that you have defined. It's basically like a reprojected longitude-latitude grid. But basically, I'm trying to use region grids to do a generalization to generalize region grids to WRF output, and also potentially for unstructured meshes or cube sphere meshes like CASM2, for example. This is in the works right now. And also landc.jl, which is for landc masks. It's now a lightweight package instead of previously I also had the functionality to download eTopo landc mask as well, or eTopo topographic masks as well, but that is now in a separate package. I am currently updating NASA precipitation and ERA 5 reanalysis to accommodate the upcoming changes to the GeoRegions ecosystem. I plan to do it over this weekend, over the winter break, so January, February as well. The documentation for GeoRegions.jl is also available. I recommend you guys go read it. And also, I'm also looking for help, or not for help, but I'm also looking for advice to how to structure the documentation. I think it's pretty comprehensive right now, but I'm also looking for ways in which to improve the ease of getting to you, or the ease in which people are able to start using GeoRegions.jl. So if you have any questions with that, please let me know, and please give me some feedback. And one last thing, I'm also planning to graduate this spring. So if anyone has any job openings in Julia or in climate dynamics, I am available. Yeah, thank you very much. Yeah, yes.
You spoke of the NASA presentation.
Yes.
Is it available?
It is available right now. It is available. It is currently available. It's currently available at version 3.1.
How far back does it work? So what is the period of data?
So NASA precipitation is available all the way, as long as GPM emerge is available, the data is available there. The GPM emerge, you can use NASA precipitation to retrieve that data. So you just have to specify the start date and the stop date. I believe I put a control on the start date that you cannot access the data before 2000 of June, but that was because during that time, NASA precipitation, the GPM, they had not made data before June of 2000 available. So anything that is from June 2000 onwards, you should be able to download up to 3 months before present day, because the final version of the data is only available 3 months after the current date. So basically the answer is yes. You should be able to download everything from June of 2000 to 3 months before the current date. Yeah, as long as it's available. Yeah.
I was thinking when you say is the coverage of all continents.
As in, it depends on what you it depends on whether on what you specify for the georegion. If you don't specify a georegion, the default will be a global coverage. So the default for the NASA precipitation will be for the globe. But the purpose of georegions is that you don't want to download the global data because the global data is huge. So if you're interested in a specific area, specify that specific area and then do the download. But NASA precipitation, GPM, iMerge, the valid range for spatial range is the entire longitude, 0 to 360, and then from -50 to 50. So those are the boundaries that GPM set, but those are not the boundaries that I set. But that's what GPM did. So I had to follow. So basically, you have to follow whatever valid data is available, provided by NASA. Yeah, does that make sense?
Yes, it does.
Okay,
Thank you so
of
much.
course.
Thank you for that. There's also somewhere we can GeoRegions who can be
Yeah,
fundraise, right?
you can get help with vector geometry and stuff. Natural GAN is what I tried. GAN.
Okay. Thank you, everybody.